This reaction, or this problem, sorry, asks, predict the major product of the following synthesis. So we have a multi-step synthesis going on here. We have 4 reaction arrows, but there are several arrows that have a 1 and a 2, indicating kind of that they represent 2 reactions. So overall, we've got 1, 2, 3, 4, 5, 6, 7 reactions occurring. So let's take stock of what we're starting with. We have a secondary alcohol. Right, so think about all the different types of things that alcohols can do. They can be oxidized. For example, they can participate in substitution reactions, elimination reactions. The reagents are going to be really key in thinking about, what happens next. So right off the bat, I look at this first reaction. We have sodium dichromate, acid, and water. That's definitely going to be oxidation. Right, so the next key thing to do is after each reaction, write out what your product is. That'll help you to keep track of where you're going. Lastly, my best advice for a question like this is don't try to do it all in your head. Definitely draw out the intermediates as you work through. That way, if you have to draw on a mechanism here or there, you can do that as well. So let's go ahead and see what happens. We have our secondary alcohol that we're starting with and our oxidation reaction. So a secondary alcohol gets oxidized to a ketone, like so. In the next reaction, we've got a Grignard reagent. So this is going to be a reduction. The Grignard reagent is going to come in and attack that carbonyl. So we're going to make O-, and then the second part, adding water, is going to protonate that to give us, oops, there's the other group there, to give us this alcohol right here. So it's a tertiary alcohol after the Grignard has reacted. Next, we're going to do tosyl chloride followed by NaOH. So tosyl chloride is essentially just converting that bad leaving group into a good one. We make OTS. And then what's really key is what is that NaOH doing here? We have a tertiary substrate. Okay, the NaOH is a strong nucleophile / base. And so what we're going to see here is an E2 elimination. And in E2, we're going to form the more stable base here, especially since the sodium hydroxide is small. So this alkene is going to be our major product. Our last reaction is an addition reaction. We see basically hydroboration oxidation. And what's really important to remember about that reaction is that it is an anti-Markovnikov reaction. Okay, and that's talking about the regiochemistry. It means that we're going to add our OH group to the less substituted carbon, which is this one. So when we do that, our product is now this molecule, still a secondary alcohol, but we basically moved the OH group from one part of our starting material to the other, and we've also added a new carbon-carbon bond. So we did a lot in this synthesis. Now we just have to figure out which starting material, or sorry, not which starting material, which of the answer choices matches our final product. And that will be D right here.